Lesson 1, Lesson 14, Module 1, Exercise 4. Find the solution set of each of these inequalities. We'll look at these in a minute, but I want you to notice that we've got a little place that you might want to highlight some properties of inequalities. Make sure you have those. So you may have noticed that one of the most important properties of inequalities is not multiplying by a negative. We're going to have to go ahead and do our trick. We're going to have to take negative 2f and add 2f to both sides, greater than 2f minus 16. We get a 0 greater than 2f minus 16. I think the best solution here would be to add 16 to both sides, add 16, add 16, and we get 16 is greater than 2f. That means division by 2, 8 is greater than 2f. There's our set notation. And if we're going to graph this on a number line, real quick, our key component's 0, so we know that we're proving that we know what 8 is. And it says 8 is bigger than everything f. 8 is bigger than everything f. Well, we didn't get ourselves an 8. 8, there we go. 8 is everything bigger than f. Open dot, no equal sign, and 8 is bigger than all f. That means 8 is above all the possible values for f, and there we are. All right, next one. This one, well, so we can multiply by a positive, we just can't multiply by a negative. I think multiplying by 12 could make our lives very easy. 1/12 of 12, there's a 1 right there for us. And we've got negative x. In here, what we have is we have 4 goes into 12 3 times. We've got less than or equal to 3. We're going to need to add x to both sides. Let's go ahead and do that the easy way. Plus x plus x. 0 is less than or equal to 3 plus x. And a little subtract 3 from both sides. Minus 3, minus 3. Negative 3 plus 0 is negative 3 is less than or equal to all things x. Negative 3 is less than or equal to all things x. So that means all things x must be on the larger side of negative 3. We have an equal sign, so it looks like we're going to get a nice solid dot here this time, because we can include 3 in our answer. And we're going to take all things greater. And there we go. All right, nice. Looks like we need to add a to both sides. Add a little messy there, but you're going to forgive me, right? 0 pair. 6 is greater than or equal to 15 plus a. Be nice to get rid of the 15. We can do that by subtracting 15, minus 15. Oh, we all picked almost the same color. And we get negative 9 is greater than or equal to a. Okay, let's think about this one. Negative 9 is greater than or equal to all things a. 0 and negative 9. Okay, we can have a solid dot. We know we can start with that solid dot. Let's go ahead and get a nice solid dot on there. Negative 9 is greater than everything a. Greater than or equal to everything a. Well, negative 9, negative 8 is greater than negative 9. It's to the right. That means that to be greater than all things a, we're going to have to go this direction. But if you think about what the words are saying, it's not so bad. All right. I think the only thing we can do here is consider distributing to both of these guys. Negative 3 times 2x plus negative 3 times 4. All of that is greater than 0. Negative 6x plus 12 is greater than 0. I think we need to add 6x to both sides. I can do that. I can put 6x here, it's positive, and add 6x over here, both positive. 0 pair. 12 is greater than 6x, and I'm going to divide both sides by 2. I can divide because that's like multiplying by a positive 1/6. 2 is greater than all things x. 2 is greater than all things x. So we know what our marker point is. We got 0 and we got 2. And 2 is greater. 2 is greater than everything x. That means 2 is above all the values, the possible values for x. And that means that it's got to be everything less than. If 2 is greater than x, then if you think about it, this is silly, but x is less than 2. And maybe that's easier. X is less than 2. And there's our answer. Yay.